Okay, the central topic of our course is elementary functions, with an emphasis on applications, although we didn't get to spend a lot of time on applications. We developed the properties of these functions and we learned how to interpret them, and we observed certain systems so that you gain the basics of how to apply these functions. But we ended up spending a lot more time developing the properties of these functions than we might have, but we did a very good job, I think, of developing these properties. You did a very good job of developing these properties. Okay, so what are the elementary functions? They are the functions you get from power functions, exponential functions, and sine functions, and combinations of these functions. They can be combined algebraically, they can be combined geometrically, and we had a geometric emphasis in this course. And the inverses of these functions and combinations of these functions. So that's kind of what this diagram is telling you. Now we begin by actually constructing graphs of power and exponential functions. We didn't construct the graph of the sine function, and we didn't get in deeply into the properties of the sine function, although everybody was able, without warning, to follow simple instructions to construct a graph of the sine function and to think about some of the properties on the final exam. Okay, so when we say constructed, we mean constructed with compass and straight edge. Now, the word constructed needs to be taken with a little bit of a grain of salt, qualified in ways that you really don't want to completely think about. So actually we did kind of a semi-construction, but I called it a construction for simplicity. Didn't want to keep qualifying the word. We'll see a little bit about what I mean. And real. Okay, real meaning that these are functions of real numbers, real variables, with real number values, as opposed to complex number values. Now, these real valued functions can be extended to complex valued functions, but this is a study that comes after 2 years of calculus and a year of advanced calculus. In the second semester of that year of advanced calculus, you would start dealing with complex valued functions, so we didn't touch on it here, although there are actually things we could have done and things that are quite interesting. The full study of this is quite advanced. So we confine ourselves to real valued functions, real valued elementary functions. We construct the graphs of power and exponential functions and explore the properties of those graphs, the geometric properties of those graphs, and relate them to the algebraic properties of the graph. So, having defined the elementary functions and learned how to make some combinations of these functions, and it's really fairly simple to make combinations. We have a picture, at least, of what elementary functions might comprise, at least a beginning picture. As mentioned, we observed certain systems. We learned to interpret the functions that relate to these systems, and in the process, learn the rudiments of how to apply these functions. We also developed mathematical properties, and it's important to understand the mathematical properties so that you understand the interpretations, the applications, and the behavior of the systems that you're looking at. Mathematical properties we looked at were the mathematical properties of the graphs and the slope graphs, both algebraic and geometric properties, but starting with the geometric properties and also looking at numerical properties. Okay, we looked at things like the graphs and the slope graphs, which correspond to derivatives and antiderivatives. So the slope graph is a graph of the derivative function. The original graph is an antiderivative of the slope graph function. We didn't go deeply into that definition. You'll see that in calculus. And some of you are a couple of years away from calculus, so we didn't go too deeply into it. The ideas of curvature and concavity, which people had very little trouble with. We didn't go into the deepest properties, but we did use these ideas, and fairly extensively. There's some big deal numbers. There's one big deal number related to power functions, another big deal numbers related to exponential functions. And by geometric and, in some cases, algebraic analysis of these graphs, we attempted to nail down these two big deal numbers. And there are also group properties. Now I have this in parentheses. We actually touched on some of the things that relate to the group properties of the various function families. And we don't talk about that too extensively, but we were right at the point where we could actually talk about the group properties, kind of coming off of the laws of exponents, the properties of the real number system, and so forth.